All right, so welcome back to the Civil FE exam review. Today in this video, we're going to be continuing our review in geotechnical engineering, and there is a topic that I want to cover today that is very conceptual. So we're going to be looking specifically at foundation types, including spread footings, deep foundations, wall footings, and mats, just to name a few. And so conceptually, you need to know like what some of these footings can do and what's kind of the purpose of each one. So have some practice problems for you all that will test concepts, knowledge, and things that you're just going to have to remember for this exam. So let's look at number one. Zoom out here a little bit. Okay. So number one says, which of the following statements best explains the considerations for choosing a mat foundation over an individual spread footing in the design of an industrial facility? Okay. So what information are we given? Well, we're given a mat. Woo. We're given a mat foundation versus a spread footing. Okay, and you're trying to find why you would lean more towards a mat foundation, right? Okay, so what would make you choose the mat foundation? All right, so a little bit of prior knowledge will go into this. So as far as formulas needed, not really any formulas needed, but you will need some PK, prior knowledge. All right, so took some notes just to share different points with you, and then we can go through the answer. So typically mat foundations, they're also known as raft foundations, distribute the load of a structure more uniformly over a very large area. Okay, so this is advantageous in situations where the soil bearing capacity is variable. So mat foundation is going to be able to distribute those loads evenly across the whole area. Okay. You also have mat foundations are effective in minimizing differential settlement. So that just means how much soil is able to break away. You don't want a bunch of different settlement and breakage in your as you're trying to keep your soil compact. So mat foundations are going to help with that. And this is really crucial for avoiding uneven settling that can lead to basically structural issues. And so also mat foundations are well suited for sites with varying soil conditions. So basically, if you have this mat foundation, you can account for all different types of soils, so that if they don't mesh that well together, still this foundation is going to help, spread that load evenly. Okay. So based on that information, all right, about mat foundations, let's look at these answers. So that's the advantages, some of the advantages of a mat foundation. So mat foundations offer cost savings due to reduced excavation and concrete usage. Not necessarily. Individual spread footings provide better load distribution and stability, For industrial structures, no, that's what a mat footing is known for. Mat foundations are suitable for sites with variable soil conditions, reducing differential settlement. So your answer is going to be C. And so also I want to go through some of the disadvantages of mat foundations because I went over the positives. So limitations of mat foundations, right? Mat foundations, they could have some limitations in terms of their load bearing capacity. In situations where you have extremely heavy loads or high bearing capacities are required, other foundation types, like maybe a deep foundation, may be best suitable. So if you got super heavy and you need to go super deep, you don't want to be using a mat foundation, right? Mat foundations could have challenges in construction on sloped sites, basically due to the need for extensive excavation for leveling to create a flat surface for the foundation. So if you got a bunch of slopes, mat foundation is not what you're going to be wanting to use. Designing mat foundations require careful considerations of the soil conditions, structural loads, and settlement expectations. The complexity of this design process may increase, especially for like a large and complex industrial structure. So if you got a bunch of different soils, a large area, right, the design gets more complex. So those are just some of the things that you will need to know for a mat foundation. Let me look up what a spread foundation, because I didn't really touch on what a spread foundation, some of the advantages of it. I'm just gonna do a quick search. And this is not in the handbook, so something that you'll need to know. So some of the benefits, it reduces cracking caused by settlement. It stabilizes soil around the base of the structure. It's good for like basements and stuff like that. So it has continuous contact with entire foundation, which reduces the risk of foundation failure. Okay, so like a mat foundation, it's only in certain locations typically, where in the spread footings it seems like it's the whole base of the structure. Again, with spread footings, they also have a limited load bearing capacity. Basically, that just means that they have a limit of the amount of load that they can carry, right? All right, let's look at number 2. So number 2 says, in selecting the appropriate deep foundation solution for a construction project, which of the following factors is considered as a key consideration in choosing driven piles over drilled shafts? So we're looking at driven piles versus shafts. All right, so we need to find key considerations. And basically, why should I choose a driven pile over a driven shaft? Okay, so what are some of the formulas we need? Not applicable. You're gonna need prior knowledge though. Okay. So the prior knowledge that you're going to need is that basically driven piles, information of what that looks like. So driven piles are installed by forcefully driving a steel, basically pile, into the ground using an impact hammer or vibratory drivers. When I was out in the field, I saw the hammer method. It's basically this constant. I don't know if you heard that from on the mic, but it's this constant like pounding, hammering into the ground, and you got to think like there's these steel beams that are getting beat into the ground, so it's really loud, very very loud. So driven piles are effective in a variety of soil conditions. Basically, they're just wanting to, by doing this, by driving these steel piles into the ground, they can put them in like 4 different corners and go so deep that it allows for that soil. It's controlling those conditions of the soil so that it doesn't move, right? When you're putting your structures down or whatever. So suitable, okay. Also, the installation speed of driven piles are relatively fast, right? So if you have a tight schedule, if you're trying to get projects done, your soil is foundations are pretty messed up, soil conditions aren't that great, driving piles would be great because it doesn't take a long time. So what I saw was a steel pile, but there are different types of piles. You have timber piles, concrete piles, and steel piles. And the specific type that you will select is based on the load requirements and your soil conditions. Driven piles can be cost effective solution for certain projects, especially when the soil conditions are favorable for driving, right? Okay, so let's look at drill shafts. Now, I've never seen drill shafts, but drill shafts, from the research that I've done, are also known as bored piles. And they're created by you excavate soil to form a hole and then placing reinforcement, okay, and concrete into the hole. Okay, so I have seen this as well. Didn't know but you're like, it's borings. I don't know if you know what a boring is, but a boring pile where they drill this hole, go deep into the ground, and then they come up with concrete, fills it up, and then basically that acts as your beam, similar to your driven piles where you're beating your beam into the ground and creating that hole just by beating it into the ground versus drilling a hole and pulling out everything and going from there. Okay. So drill shafts are suitable for a wide range of conditions. Drill shafts can be designated to reach greater depths compared to driven piles. So depending on how deep you want to go, you would choose a shaft, right? Okay. Load capacity. Drill shafts can offer a high load bearing capacity, making them suitable for supporting heavy structures and resisting lateral load. So if you want something that has the highest probably load capacity, you're gonna want to go with drilled shafts over your driven piles. Okay. So based on that information, why would we choose a driven pile over a driven shaft? Well, a driven pile would be, so when we listed those things. So A says soil compaction efficiency. So no, neither of those deal with that. Installation depth, I would choose, if I needed to go super deep, I would choose a drilled shaft. And so we're trying to say, why would we choose a driven pile over a drilled shaft? So no. Construction speed. I mentioned that as you're driving piles is very fast versus shafts. So that one for now is correct. And then the load bearing capacity. Drilled shafts beats out driven piles. Is one of the highest capacities, load bearing capacities. So no. So answer is C. If you missed this, you can I have some extra notes on the actual worksheet. So if you don't see any of this on your problem sheet, go to the solution sheet, download that, and a lot of these notes that I went through are on there as well. So, all right, let's look at number 3. All right, so number 3 says, in the design of a shallow foundation for a residential building, what factors or primary factor would influence the choice between a square and a rectangular spread footing? Okay. So let's write out the information we're given. We're given a choice between, we have a square and a rectangular spread footing. Okay. So we're trying to find what's something that is primary factor would influence the choice. So find what heavily influence choosing between, your square and rectangle. Okay, so no formula is needed, but you will need some prior knowledge, some PK. All right, so prior knowledge that you would need, so when choosing between square and rectangular spread footings for basically a shallow foundation, there's several factors related to soil conditions and structural requirements that will influence the decision. Here's a few factors. Load distribution, for sure. The distribution of loads from the structure play a huge role. So if the loads are uniform and symmetrical, a square footing may be more suitable. If we think about this and just draw going to draw a square footing. And then a rectangular footing. And we'll just say this is a top view, right? And let's say we have loads that are coming at each corner, right? Versus a square, the loads are coming at each corner, right? Well, these loads, if the same load is applied, all right, for a square, it's a lot more balanced versus you got these forces coming down at those green locations, right? They're coming down at all these green locations. What that could do is if that's the same load, it's not really distributed along this distance, right? So what could happen is that load distribution, since it's not really uniform, it could cause a crack or break into the structure or into the soil, right? Versus you have this balanced here, right? Everything's even and it doesn't really have the same distance that is loaded coming down. All your distances are even. So along that area, your load distribution is going to be a lot more even. So just something to think about. Soil bearing capacity. The bearing capacity of the soil beneath the foundation is a critical factor. If the soil has uniform bearing across the entire footprint, a square footing may suffice. If the bearing capacities vary spatially, a rectangular footing can be designed to distribute the load. So if you got different loading, right, more on one side than the other, or something happening, you may need a rectangular footing instead of a square footing. So based on our answer choices, you got A, architectural preferences, and aesthetics. No, we don't care about how pretty it looks. Soil bearing capacity, yes. Differential settlement conditions, not so much. So what mat footings are for. Cost complications of excavation and formwork, not really. Mat foundations have kind of an issue with that because of slopes. Of it being so costly to excavate more, but our answer is going to be B in this case. So a few conceptual things that hopefully was helpful for you. In the next video, we're going to be looking at consolidation of differential settlement. I will see you in the next video.